XQA National 5 Maths 2016 Paper 2 Question 1. A drinks manufacturer is reducing the sugar content of their fizzy drinks by 8% per year over the next 3 years. The sugar content is 35 grams. What is it worth after 3 years? So there's our key numbers, 8%, 3 years, 35 grams. So dealing with a percent first, it is going down. So it's 100% minus 8%, which is 92%. Which is 0.92. So that's our multiplier. So we take our amount, which is 35 grams, we times by our multiplier to the power of how many years it is, which is 3 years, and we get a calculator out and work it out. 35 times 0.92 to the power of 3 is 27.25408. 27.25408. grams. Just check, is there any particular rounding involved? Nope. So chances are there will not be a mark for rounding, so you could just write it like that. Or if you want to neaten this up a little bit, 27.3 or 27.25 would be a acceptable answer. I'm just going to write 27.3 grams. Even 27 would be fine. Couple of past paper questions standard form. So 2016 paper 2 question 2. A pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Calculate the weight of one pollen grain in grams. Give your answer in scientific notation. So it's asking me for the weight of one of the things. So I need to divide by 1.5 times 10 to the 9 to find one of them. So the sum I'm going to do is 12 divided by 1.5 times 10 to the 9. And I'll put that in brackets to remind myself that when I get my calculator out, I'll need to use a brackets around it. So that's 12 divided by 1.5 to the power times 10 to the power of 9. That gives me 0.0000000008. So I just write that down. 0.00000008. I have to give my answer in scientific notation or standard form. So I just do that in the same way. 8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 9. XQA National 5 Maths 2016 Paper 2 Question 3 on vectors. The diagram below shows a parallelogram. AB is represented by U, shown in the diagram, and BC is V. We have to express B to D in terms of U and V. So we need to start at B and get to D somehow, but we don't know that one. But we can take any route we want, remember? So we can either go along here and then up there. So what would that one be? The same as that one, because it's the same size and direction. So I'll note that's V. Or you could go along here and along there. And that one would be the same as this one, but the opposite direction. So that direction there would be U. So let me just go this way. Minus U plus V. Done. Minus U plus V. Or you could have written V minus U. Same idea. There you go. XQA National 5 Maths 2016 Paper 2 Question 4 on factorising. Factorise through with 3x squared minus 48. Well, first thing we'll check if there's a common factor. Well, there is. 3 is a common factor, so I can divide by 3 to get x squared. And 3 into 48, well, 3 into 4 goes 1, with 1 left over. 3 6s are 18. So we get 3 bracket x squared minus 16. But that's a difference of 2 squares. So how do you factorise that? You know it's a difference of 2 squares because you've got an x squared or something squared, and then take away a number, which is a square number. So that's just double brackets. X in each place, square root of 16 is 4, so that goes in each place, plus in one bracket, minus in the other, and you're done there. XQA National 5 Maths 2016 Paper 2 Question 15. I had this question, and with the calculator, you can see what angle we want in this one, but we'll start anywhere you want. So, looking here, we've got 1, 4, 3, so I might as well use angles on a straight line out to 180, and do 180 minus 143 is 37. So I can write that that's 37 right up here. And then we can move down a level is how I put it. So it's a Z angle or an alternate angle are equal. So I can get this is 37 down here. Then a little trick. We've got a radius meets a line outside the circle, a tangent at right angles. These two angles add up to 90. So I can do 90 minus 37 because that's a right angle. and that gives you 53. So we now know that's 53 degrees, and because this is symmetrical, that is also 53 degrees. And therefore, angles in a triangle add up to 180. So I can do 53 plus 53, which is 106 degrees. So our angle ABC is equal to 180 minus 106, which is 74 degrees for our final mark. So a mark for getting 53 and 37 and a mark for your 74. Now a mean and standard deviation question, SQA National 5 Maths 2016, paper 2, question 6. Jack called his internet provider on 6 different occasions to report a connection problem. On each occasion he noted the length of times he had to wait, times in minutes are these, calculate the mean and standard deviation of these times, and then there's a comparison question, which we'll get to in a moment. So for the mean and standard deviation, the bit I need is just these numbers. To get our mean, well, since we're doing mean and standard deviation, we just jump straight into a table. So remember it's x, and that's all our numbers. X minus x bar, because remember our standard deviation formula from the start of the exam paper is the square root of the sum of x minus x bar squared over n minus 1, and I always use this one rather than the alternative, but you can. That gives me x minus x bar squared. So there's my table nice and neatly laid out. I'll add up all of these here to get a total and then work out the mean. 78, so that means that my mean is equal to 78 divided by how many numbers I've got, 1, 2, 3, 4, 5, 6. So divided by 6, we get 13. We've worked out our mean, we can underline that. Let's go into our table, so we need to take away 13 in the middle. So that gives me 0, 3, minus 3, 9, minus 8, and minus 1. We then square each of the numbers on the end, so that is still 0, 3 3s is 9, 3 3s is 9, 9 9s is 81, 8 8s is 64, 1 times 1 is 1. So once we've got all those numbers, we just add them all up. 9 plus 81 plus 64 plus 1, and that gives me 164. And that is our key number that we're going to use in the top of our formula, divided by 1 less than the number we've got, which is 1, 2, 3, 4, 5, 6, so it's 5. So our standard deviation is equal to the square root of 164 over 5. Square root, open brackets, 164 divided by 5, close brackets, is 5.727, or 5.7 minutes to 1 decimal place. Technically on the mean that would be minutes as well, but most of the time you won't lose marks for missing that on the mean and standard deviation. Part B says, Sophie called the same internet provider on several occasions to report connection problems. Her mean waiting time is 15 minutes and the standard deviation is 4.3. Make 2 valid comments. So 1 comment to compare the mean and 1 to compare the standard deviation. Let's start with the mean. Always for mean you're saying on average. You always need to say on average, otherwise you won't get a mark. So on average. And then just compare Sophie's waiting time to the previous person's. So the previous person's was 13 minutes. Sophie's is 15 minutes. So Sophie's waiting time was longer, or bigger, or greater. Bigger means that on average it's bigger, but you need to use the word on average. Okay, let's compare the standard deviation. So there's a mark for the mean, and then to compare the standard deviation is all about consistency or how spread out the data is. So the previous person's standard deviation was 5.7 minutes, and Sophie's standard deviation is 4.3 minutes. It's went down, so Sophie's waiting times, which is what the question is about, are more consistent. So that's all we have to say. Sophie's waiting times are more consistent. Now, on both of them, I've not actually referred back to the numbers. It used to be that you had to do that, but now SQA have recently not been actually saying you have to do that. But let's just to be on the safe side, on average, Sophie's waiting time was longer because 15 is bigger than 13. We could say there. And Sophie's waiting times are more consistent because 4.3 is less than 5.7. Just to be on the safe. SQA National 5 Maths 2016, Paper 2, Question 7. A carton is in the shape of a large cone with a small cone removed. So it's a takeaway. The large cone has a diameter of 32 and a height of 24. The small's got a diameter of 18 and a height of 13.5. Calculate the volume of the carton. And again, rounding involved to two significant figures. So we do the volume of the big cone minus the volume of the small cone. So let's just do that, right? So the volume of our big cone is, remember, volume of a cone is 1/3 pi r squared times h. Given at the start of the exam paper, 1/3 times pi times, now the radius is going to be 16 because it's half the diameter and the height is 24. So we get a mark for doing that and getting an answer. The answer to that would be 6433.98 with a bunch of other numbers, centimetres cubed. Now we do the small cone. The volume of the small cone, 1/3 times pi times the radius, which is 9, half of 18, squared, and times the height of the small cone, which is 13.5. We put all that in our calculator and we get 1145.11 and a bunch of other numbers, centimetres cubed. So we've got one answer, two answers for 2 marks. And then we get a mark for knowing that we need to take away. So our volume is equal to 6433.98 minus 1145.11. And that gives us, using the unrounded figures to take away, 5288.87. And then we get, for rounding our final mark, 2 significant figures it says. So that equals 5300 units, centimetres cubed, for 5 marks. Looking at the sine rule first of all. So we're going to look at a few National 5 questions and get into it straight away. A set of step ladders has legs 150 by 140, SQA National 5 Maths 2016, Paper 2, Question 8. When the step ladder is fully open, the angle between the longer leg and the ground is 66. Calculate the angle x, which is shown here. So we really don't need this picture. So a reminder of the sine rule from the start of the exam paper. You get A over sine A equals B over sine B equals C over sine C. You can just copy that. And basically it's pairs. So if I call that letter A, that goes with this one, which is A. I could call that B, and that goes with this one, which is B. And obviously there's nothing on the other one, so I can just ignore them. So I've got A over sine A, 140 over sine 66, equals B over sine B, 150 over sine X. And you will get a mark for that substitution. You can now rearrange that to make sine X the subject. So I always think of it as a cross. This times this, 140 sine X, equals this times this, 150 sine 66. So now dividing by 140, sine X is 150 times sine 66 over 140, and you would get a mark for that. And then your final mark for finding X. So you need to do the inverse sine, because they've got sine X, so X equals the inverse sine of 150 times sine 66 divided by 140. Now you can do all that in a calculator in one step, where it's inverse sine, open a bracket, 150 times sine 66 divided by 140, close your bracket, and you will get an answer of 78.18. or 78.2 degrees. If you prefer, you can work out the answer to that first and then do the inverse sine of just that answer to get the same thing. Just make sure you don't round too early. X-Grade National 5 Maths 2016, Paper 2, Question 9. Express x squared plus 8x minus 7 in the form x plus a squared plus b. So this is called completing the square. So how does this work? Well, we half the middle term. So it's x plus 4 all squared. We immediately take away this number squared, which is 4. So it's 4 squared. And then we've still got minus 7 on the end. So that gives me x plus 7 4 squared minus 16 minus 7. X plus 4 squared minus 16 minus 7 is minus 23. And we're done there. 2016, Paper 2, Question 10. Simplify n squared cubed times 10 to the n to the minus 10. Give your answer as a positive power. So let's start with the n squared cubed. That gives me 2 times 3 is 6 times n to the minus 10. Times in indices, which means we can add the powers. So that gives me n, 6 take away 10 is negative 4. Leave your answer as a positive power. The last little thing then, 1 over n to the 4. And 1. It's Green National 5 Maths 2016, Paper 2, Question 11 on similarity. Two pictures are mathematically similar in shape. The cost is proportional to the area. The large picture costs $13.75. Find the cost of the small picture. So it says cost is proportional to area, so I need to find the area scale factor. So starting with the linear scale factor, I have to find the smaller picture. So I start with the small side over the big side. So the linear scale factor is 60 over 100. Simplify that to 6 over 10, which is 3/5. So that means that my area scale factor is simply my linear scale factor squared. That's 9 over 25. And remember, this is a paper 2 question, so it could be calculator you use. So then that means that our cost is simply 9/25 of £13.75. So I'll just get my calculator and work that out. 9 divided by 25 times £13.75 is £4.95. And we're done there. Okay, changing the subjects, but when there's squares and square roots involved. So this is 2016 Paper 2, Question 12. Change the subject to k, but there's a square root. So I'm going to have to eliminate that square root. Well, the opposite of a square rooting is to square. So I'm just going to square both sides. So that gives me L squared. And when you square a square root, this root just disappears. So it gives me 4kt minus p, whatever's under that root. Now I can change it to k in the same way. Adding p to both sides, I get L squared plus p is 4kt. Dividing through by anything which is attached to that k, which is 4 and t this time, we get L squared plus p all over 4 and t equals k. Or you can write it the other way, k equals L squared plus p over 4t. Algebraic fractions, SQA National 5 Maths 2016, Paper 2, Question 13. Express this algebraic fraction as a single fraction. So we have to add or take away a fraction. So we just times the bottom together to get a common denominator. So times in them, our common denominators, x minus 2 in brackets and x plus 1. And then we can just think, well, this one's been times by that one. So it's like a little cross, 3 bracket x plus 1. And then this one's been times by that one. So crossing over plus 5x minus 2. Now, if you can get that far, then all you're doing is expanding and simplifying brackets. So expanding and simplifying brackets, on the top, we get 3x plus 3 plus 5x, and then 5 2s are 10. And you might as well just keep this as x minus 2x plus 1 because factorise is better than unfactorised. The only reason we're unfactorising the top is to create all the x's together and all the numbers together, which we might then factorise if we have to. So that gives us on the top 3 plus 5 is 8x, and then 3 take away 10 is minus 7, all over x minus 2 and x plus 1. And the top cannot be factorised or anything else. Metric equations, SQA National 5 Maths 2016, Paper 2, Question 14. This is 2 tan x plus 5 is minus 4. So I'll take away 5 from both sides to start with to get 2 tan x degrees is negative 9. Divide through by 2 to get negative 9 over 2. So now we never do the inverse tan of a negative, of inverse cos or sine. We just do it of 9 over 2, but then pick the correct ones. So don't write x equals, just do the inverse tan of 9 over 2 at the side and work out what that is using a calculator. I get 77.47 or 77.5 to 1 decimal place. And now we can draw a cast diagram. So remember, that's 180 minus, 180 plus, and 360 minus. And the two I want this time, well, normally for tan, it would be A and T if it was positive, but since it's negative, I pick the other two. So I need to do 180 minus and 360 minus the answer I got. So x degrees, to be very clear, is 360 minus 77.5, and it is also 180 minus 77.5. 282.5 for the first one. And for the second one, 180 minus 77.5 is 102.5. Just double check. It's between 0 and 360. Yep, so we're done. Pythagoras and Circles, SQA National 5 Maths 2016, Paper 2, Question 15, had this kind of picture where it is a bottle of perfume and it's part of a circle, and it says this is the height of the label, the centre is the circle of O, AB is a chord length 9, radius is 6.6, calculate the height, so we have to go from here all the way up. So if I take that line straight into the circle, I've got the radius already, so I just need this missing bit. So I add that line in. So we can call that x, and this will be 4.5 centimetres because it's half of 9. And then we're good to go. So I mark for getting that triangle, and then x squared will be the hypotenuse squared minus the other side squared. Remember, x, we need to square root it, so we can do 6.6 squared minus 4.5 squared and get an answer then square root it, or you can just put that in brackets in a calculator and you'll get an answer of 4.8. So then the height of our label is just going to be 4.8 plus the radius, which is 6.6. That gives you 11.4 centimetres. And notice I'm not rounding, so I'll just put dot, dot, dot. 11.4 would be fine. And that is a nice 4-mark question. SQA National 5 Maths 2016, Paper 2, Question 16 on the cosine rule. We've got this diagram here with a bunch of numbers. A to D is 4, D to B is 6, and A, E, and EC are 3. But it's all shown in the diagram. We have to calculate the length of B to C, so let's highlight that. That's this one here. So I'm just going to put a little letter on there. Let's just call it X now. And it's a tricky cosine rule one because there's no obvious angle, but I have got 3 sides of a triangle, 1, 2, 3, including the one I'm trying to find. So I know it's a cosine rule. So if I knew this angle here, opposite the side I'm looking for, I'd be good to go. But luckily I can do that because I've got a right angle triangle here. So if I call that cos A, then cos A is equal to adjacent, which is 3, over hypotenuse, which is 4. So that's 3/4. The other way you could have got that would be to use the sine rule twice, but that's the simplest way. So now if that's A, my little x has become A, little a. And then at the start of the exam paper, the cosine rule says A squared equals B squared plus C squared minus 2BC cos A. I know cos A is 3/4 already though, so I don't need to work out the angle A. I can just substitute in 3/4 straight away. So my B and C, remember, are the sides which are either side of the angle. So that's these two. So I could write 10 for this side. Let's call that B. Or C, actually, if you want to be consistent with the diagram. Let's just do that. And 6, which we could call B. 3 plus 3, 6. So we've got 6 squared plus 10 squared minus 2 times 6 times 10 times 3/4. Remember, this is a calculator paper. So you've got 36 plus 100 minus 2 times 6 is 12 times 10 is 120 times 3/4. So that's 136. 4 goes into 12 3 times, so that's 30 times 3 is 90, but don't worry, it's a calculator paper, so use a calculator if you have to. 136 minus 90 is 46. So we get a squared equals 46. So a is the square root of 46. Even I can't do that without a calculator. So square root of 46 is 6.78. Now let's just check if there's any units or rounding to do in this question. 1 decimal place, so that equals 6.8, and the units were centimetres. And we're done there.